So till now from the last video, we created a simulation to, of course, simulate memory leaks, right? So we created grids and we remove grids. If you haven't seen the last video, I'll just link it here somewhere. You can just go have a look and come back to this, right? So in the last video, we sort of had this small demo of creating grids, removing grids, and we saw that the initial state and the final state, even if visually and like from an intuitive perspective, utility perspective, or from a feature perspective, is the same. The resources consumed were in the same, which should be ideally. So that's an indication of a memory leak. So if that happens with whichever application you're writing, it's very high likely that you are doing something wrong. Like if from a feature perspective or from a visual perspective or like whatever, right? So if you're not holding any state, the resources consumed by it should be predictable. That's what. So yeah, let's solve it. Let's see what the issue was. So we discussed about reachability, right? So garbage collector will only come into place when something is not reachable. When something is not reachable, it should not be anywhere in the DOM tree in our particular use case. But what we are doing here is, which a lot of people do, we are just setting the display to none. So this is a CSS property transformation that we are doing, but the element is still there in the DOM. So even if you sort of simulated the behavior of removing the element, you didn't actually remove it. You just like hide it from the whole UI. That's what. So right. So what? Let's try doing this. Let's try doing remove. So what it will do is it will remove it from the DOM, and so it will make it unreachable. When you did this, if you wanted to access it, you could have still accessed it. Like there could have been a query where instead of not, I'm doing, let's say, grid container get all the elements where display is none. So it's still accessible. Even if you don't need it, you kept it accessible mistakenly because you changed the CSS property. So when you are saying unreachable, from your point of view, you should be very clear that if you don't need it, then just discard it. So basically it should not be accessible anyhow. So that's when the garbage collector would come in and clear it out, right? So when you do remove, there is no way for you to access it after you remove it, right? So it's gone. So the garbage collector would now know, okay, so this thing is removed, and what I can do is I can get rid of it, right? So it will clear the memory, it will clear the resources that it consumed so that it can be used by something else, which I would assume is sort of a behavior or an intuition that you would form if you're working with this kind of use cases, but the implementation didn't flow on the same lines because of maybe some assumptions or whatnot, right? So yeah, let's try this now. Let's reload the page and we start recording. Let it run for maybe 3 seconds, 4 seconds. We clear the garbage, existing everything. We start creating grids. 5 grids. We start removing them. We clear the garbage. We start creating grid. We start removing them. We clear the garbage. Let it run for maybe 4 seconds so that we have enough padding on the end. Stop it. So this is the ideal graph, right? So as you can see, if it's visible properly, so I just bring it down. See, so this is the perfect condition that it should be. So what it did was, whenever you created grids, it consumed memory, consumed listeners. Like the yellow is the listener, blue is the memory. So this one is the listener. So listener, where it comes in is the mouse over listeners that we added to show the colors. So if you have not seen the last video, I'll just demonstrate once. You create a grid, we hover over it, and when we hover, it shows colors. So something is listening for a hover event. So it's like when hover, show color, like as simple as that. When X, do Y. That's what. So those are listeners. We discussed those in a lot of videos in the past. So let's remove this. So let's study the graph. So here we can see the memory goes up, stays there for a while. We manually trigger garbage collection here. If we wouldn't have manually triggered, it would have collected it on its own, but the time it would have taken is a bit unpredictable. But yeah, we triggered a GC here by clicking the dustbin button for test, and it cleared everything out, and we are back to the initial state, right? We are back to where we started. Then we did the whole thing again. The memory went up, the listeners went up. We triggered GC after removing everything. It went to the starting phase. So here we don't have any memory leaks. Why? Because we started with the same amount of water. We started with X amount of water. We redistributed the water among different glasses, and we recollected back the water. We get the same amount here, which was not the case in the last example, if you remember, right? So that's a sort of analogy that you can use to connect your browser DOM with glasses of water, for instance, for understanding memory leaks. So yeah, that should be it for this video. I hope it was helpful, and if you found it helpful, of course, maybe share it with your friends, drop any feedbacks if you have any in the comments, or maybe message me on Twitter. And yeah, see you folks, bye.